All right, with this video, I want to determine the solution to this inequality. 1 over x plus 3 is less than 2. Now, 1 over x plus 3 is what we call rational expression because it's written in fractional form. Okay? What I have here is a graph of 1 over x. You can see that that is right there. That's the graph of y1 equals 1 over x plus 3. Okay? And from that graph, I want to see when is it less than 2. So I can go back and y equals, I can, in y2, I can just put the horizontal line y equals 2. Now, if I now go and look at the graph, okay, what I'm interested in is when is this graph of 1 over x minus 3 less than 2, okay? Well, first off, okay, you have to agree that there's something happening at 3, all right, because, and this is why I've been telling you all along from the very beginning, x is not allowed to be negative 3 here, okay? And you can see the impact of that on the graph, which is to cause that the asymptote line. Now, so it looks like if I can find this point of intersection, which certainly I can, okay, using my F5, and going to my intersection option, number 5, and hitting that, and then coming in close proximity. I want to be on one of the curves. I'm on one. I mean, on the 1 over x plus 3. I enter, it jumps to the other one. I enter. I want to hone in on that from the left side and the right side. So here's the left side of that intersection, and there is the right side of that. Close enough. And lo and behold, it's going to tell me any time now. I hope it seems to be wrestling with that idea. Let me try it again. It seems to be busy. All right. So, okay, so I'm back, and it looks like it found that it is going to happen at the x value of negative 2.5. So, okay, the question is, what is, do I say, okay, that it is okay to say all the x values less than negative 2.5 are going to satisfy that? Well, no, not really, because look at what's happening, okay? Less than 2.5, okay, is going to cover me on this. And then I got this branch over here, which is always going to be less than that as well. So obviously, you know, we're going to have to develop a technique to look at this. The one technique that you don't want to do, okay, is you don't want to simply cross multiply. You cannot cross multiply because you're dealing with an inequality. And you know when you multiply in an inequality with a negative, it reverses the sign. And you say, well, if I'm cross multiplying with x plus 3, that could either be positive or negative. So cross multiplying is not the way to go. Do not cross multiply. The only thing we can do is what we've done all along. We want to compare this to 0. So what we want to do is we want to swing that 2 to the other side, and that comes over as a 2, which won't interrupt the inequality, but now it's set equal to 0. But now I can't do anything because what I need to do is I need to put these on a common denominator, okay? Because again, my sign table is only built around factors, and I don't have any factors here. So I have to write this as a series of products. So basically then I can put both of these on the common denominator, which is x plus 3. So this one is going to be unchanged, this first one. And that's going to be minus 2 times, and it's going to be over x plus 3. So I'm going to have to multiply that numerator by x plus 3 as well. Okay, and now we can write it as a single fraction, okay, over x plus 3. And I got 1, don't forget we have to distribute with that negative sign, so minus 2x, okay, and minus 6. So let me clean that up a bit. So that's going to be, is going to be equal to, this will clean up to be what? Negative 2x minus 5 over x plus 3 is less than or equal to 0. Now, what do we want to find? Well, we want to find, it's already written as factors, so we're good to go on that. We know from the beginning x can equal negative 3. That's going to be included in our sign table, okay? So negative 3 is a value in our sign table. And also what? Well, what causes this numerator to go to 0? Well, that's going to be negative 5 halves, right? So x equals negative 2.5. So those are our values in our sign table. Okay, so we're getting negative 3 and negative 2.5, 2.5, if you will. Okay, and so negative 3 comes from the x plus 3 factor, and this comes from the negative 2x minus 5. Okay, so a value thrown in, okay, in there. Anything less than negative 3, negative 10 plus 3, that's going to go negative. Now, value in between negative 3 and negative 2.5, that's negative 2.5, right? Okay. Well, I mean, you know, negative 2.75, negative 2.75 plus 3 is going to go positive, right? Okay. And then a value north of negative 2.50, that's going to go positive here, okay? All right, so now in the second grouping, in this factor, 2x minus 5, the sample value, negative 10, negative 20 minus 5, negative 25, that certainly goes negative, okay? Let's check, double check that. Okay, I was a little much in a hurry there, okay? So negative 10 goes in this, negative 10n times negative 2 is positive 20, minus 5, so that's going to be positive, okay? Negative 2.75, let's say we put in. Negative 2.75, negative 2.75 times negative 2 is going to be a positive. In excess of 5, less 5, that's going to be a positive number, okay? And something greater than negative 2.50, 0 in there is going to make that a negative, okay? So what do we got? We've got the product, or in this case a quotient, but the same rule, okay? Unlike signs will produce a negative. Like signs will produce a positive. Unlike signs will produce a negative again. So what do we conclude on this? We conclude that this expression is less than 2 on the interval running from negative infinity up to negative 3. Can we include negative 3? No, because we have the condition up here, x can never equal negative 3, so we can't include that. In union with, can we include the negative 2.5? Yes, we can. In union with negative 2.5 all the way up to infinity, and that should agree. Let's pull up that graph again. Okay, where is it? There we go. Okay, so here we go. We're certainly coming up to negative 3. We're always underneath the we're always underneath the axis actually, but so we're always going to be negative, okay? But from the original graph, that's always going to be underneath the line y equals 2, and then we got a brief interval where we're above, just between negative 3 and negative 2.5. That's the only interval for which this graph will be north of that line y equals 2. And then there it goes to the other, from negative 2.5 all the way out to forever, where it's going to be underneath that, okay? So, you know, when you have these kind of expressions, the bottom line is you can't multiply by anything because you're dealing with an inequality. And when you multiply an inequality, that can reverse the sign. And you don't know whether this expression at some point is going to be positive, some point it's going to be negative. So don't cross multiply. Just swing everything to one side, okay? Put them on a common denominator, get your factors, determine what offsets the numerator to 0, what offsets the denominator to 0, put those values into your sign table, build your sign table around there, You have to be careful here with these guys that have lead-off negatives. The signs usually are in the reverse order than you might expect, so just put your sample values in and be careful about that, okay? So that does it for that type of a problem. So you got a couple problems that we're going to do in class with you tomorrow on that, so you'll be on top of it, okay? Good enough.